CQS, or Command Query Separation, states that a method should either read or write, but never both. In other words, asking a question shouldn't change the answer. We call that question a query. When we want to retrieve information, we invoke query methods. This loads or calculates the information and then returns it, but must not itself have any side effects. That is, it must not change the data. Methods that make changes are called commands. These are instructions to change the data which must not return any data themselves. A common example of violating CQS is dequeuing from a queue. The dequeue method returns an item at the top of the queue, like a query, but also changes the state of the queue. Calling dequeue for a second time would give us a different result. So the act of asking the question has also changed the answer. If we wanted to redesign this to follow the CQS principle, we would split into two different methods. We would use one method to view the item at the front of the queue without changing any state, and then separately call another method which removes that item without returning anything. We can query again to see what is now at the front of the queue. So that's CQS. CQRS stands for Command Query Responsibility Segregation. It takes CQS a step further. Rather than a CRUD design, where we create an entity and then read back that same entity, CQRS treats reads and writes as entirely separate subsystems. Not just the methods, but different classes that can have different models of the same data. CQRS doesn't expect the response from a query to be the same data structure used for commands. And that's all there is to CQRS. Separate models for reading and writing. But why bother? Well, sometimes it comes down to just separating concerns. In some systems, such as those with task-based UIs, reading and writing are clearly different responsibilities, and splitting them up can make the system easier to reason about. But not always. Some systems naturally have one unified model where you edit data and then expect to read it back in the same structure. Trying to follow CQRS here would just complicate the design. Reading and writing each bring with them different problems to solve, particularly at scale. One of the main benefits of CQRS is that the two separate subsystems can evolve independently. We might want to optimize query performance by implementing a caching layer, or we could read from read-only replica databases to reduce load on the main database. This would also give reads higher availability, because if one database fails, we have other copies to read. And because queries don't have any side effects, we can safely retry the call. Perhaps queries get too complicated for our database to execute, and we want to pre-compute different views of the data. For example, building each user's homepage in advance so that the data can be loaded quicker after they log in. This is why CQRS is often discussed alongside other concepts such as event sourcing and eventual consistency. Using CQRS might make adopting those ideas easier, but they're not essential. Writing data, on the other hand, brings very different problems to solve. Like, what do we do if a command fails? Or what happens if multiple concurrent processes try to modify the same data? This is where ideas like using aggregates and domain-driven design or putting asynchronous commands on a message queue come into play. But again, these are not necessary in CQRS. It's just about having separate read and write models that can evolve independently so that we can make different trade-offs for each subsystem. The rest is extra.